When asked to calculate the nth term of a linear sequence, the first thing we need to do is find the common difference. So to get from 5 to 8 I add 3, 8 to 13 I add 3, and from 11 to 14 I add 3. Because I'm adding 3 each time, I can write 3n. Now 3n represents my 3 times tables, so I could write my 3 times tables above my sequence. Now to find the next part of our expression, we need to work out what the difference is from 3 to 5, 6 to 8, 9 to 11 and 12 to 14. In each of those cases, I'm adding 2. So my sequence is the 3 times tables, but I've added 2 to each number. For my next sequence, I work at the common difference, so I'm adding 5 each time. So I can write 5n. That represents my 5 times tables, so 5, 10, 15, 20. To get from the 5 times table to my sequence, I need to subtract 4. So my nth term is my 5 times tables minus 4, so 5n minus 4. Alternatively, you can have a sequence that is going smaller. So to get from 20 to 16, I'm taking 4. From 16 to 12, I'm taking 4. And from 12 to 8, I'm taking 4. So I can write minus 4n. That represents my minus 4 times tables. What am I doing to minus 4 to get to 20? From minus 8 to get to 16 and so on? Well, I am adding 24. So my sequence is minus 4n plus 24. For my next one, I work at the difference. Each time I'm taking away 2. So I can write minus 2n. That represents my minus 2 times tables. And what am I doing to my minus 2 times tables to get to my sequence? Well, I am subtracting 3, so it's minus 2n, take away 3.